Just I'm coming to you live from Vail, Colorado. And I just partly want to mention that because my backdrop probably looks weird, but also, I'm just helping my daughter post-op after her knee surgery, and in the middle of this call, you never know, I may get called to do something. So if I say, "Whoa, I got to go do something," you guys just talk amongst yourselves. So with that, let me get started. I'll share my screen. That should be it. There we go. So I titled this Toward a Knowledge Ontology. And I got to get you guys out of my way. I got to shrink you there. So, so I'm a little bit out on a limb here on this one because I think this talk, despite the fact that I've gone through it several times, is either pretty profound. Might have hit on something here, or it's completely daft. And I don't think it's anything in between. I think it's not this sort of feel good, nice, incrementally kind of thing. I think we ought to either say, "Wow, yeah, let's do this," or "No, come on, forget about it. It's already handled. Forget about it." So, so what are we even talking about? A knowledge ontology. Isn't everything we do a knowledge ontology? We wake up every day and interview people and draw models and put stuff in triple stores. Um, we build these ontologies. They contain knowledge. I mean, what else do you need? Well, let's look at it. Let's look at what we actually have and see if there's something missing that we've been staring at and not seeing. That's kind of what I'm shooting for here. And when we stumble across some of these things, I'm going to suggest, do we force fit them someplace where they don't belong, or do we just ignore them, or what, or is everything fine and I'm the one out on the limb here? So let's go with some concrete examples. The Empire State Building has a lot of concrete. That makes for a nice example. Um, most people think of real world facts as knowledge. These are the kind of things you could win Jeopardy on. The Empire State Building is at 355th Avenue. That's knowledge, especially if you want to go find it. And the fact that it happens to be 1,400 feet tall is knowledge. And, we may know that it was designed by this particular architectural firm back there in the late 20s, early 30s. And you look at all that and you say, yeah, that's knowledge. I guess that would fit that category. We already know how to deal with this stuff. We call it an A box. We say these are facts. We say these are triples. They might be object triples like the the architectural firm. They might be data type triples like the height. The address could go either way depending on how you model it. But we know how to deal with that kind of knowledge. So this isn't it. This isn't what the problem was. We also know a lot about the world based on sets or types. We know that the Empire State Building is a skyscraper. And therefore, we know that it's a building. And therefore, we know that some humans built it. It's an artifact. It's a result of intentional construction. And we also know that it's what we call landmark, meaning you could wayfind. It's attached to the earth, and you can find things relative to it. So that's all. That's knowledge. That's okay. But of course, we already know how to deal with this too. We call that the T box, the terminology box, the ontology itself. But that we got that handled. That's not the problem either. That is knowledge. We got that in the knowledge graph. We also know a lot of the things about the Empire State Building. We know that its style is Art Deco, and we know that it is a tourist attraction. People have offices and residences and there's all kinds of things that we know categorically. And these categories are very helpful for us, and we would call that knowledge. But we know how to do that, and we call that a C box. Others call it a taxonomy. It's just, ways of tagging, categorizing things that you already know something about. So at some level, it feels like we got this problem handled, but there's other stuff lurking right around there that I'm not completely sure we have a codified way of dealing with. So for instance, with a skyscraper, we know that they typically have steel frames and curtain walls. Um, we know, for instance, or some people know, that you get to a certain height and the real design constraints are no longer load factors, which they are for smaller buildings, or earthquakes, which, because those are pretty solved problems. Turns out wind is the issue in designing a skyscraper. And then there's just mundane things that we know as normal old city dwelling people, skyscrapers have elevators. You know, Theoretically, they don't absolutely have to, but it'd be a pretty useless skyscraper if all they had was stairs. And we know that skyscrapers are built in large cities because real estate's high and therefore you go up instead of out. So that's knowledge. And I would suggest that we don't have an obvious and automatic place to put stuff like this. So, the question is, where does, and maybe it's not important. Maybe we can literally ignore it, but if it were important, what would we do with it and where would we put it? So I'm going to have a few more examples because this stuff comes up and it comes up at the periphery of our projects over and over again. And we haven't, I don't think, have actually solved what to do with this. One of the first times I came across it, we were doing a project for Standard and Poor's, the Platts division, and we're building a knowledge graph. And at one point, one of the subject matter experts said, "Boy, this would be kind of cool if you could put the sort of information that somebody new to Platts doesn't know, but somebody who's been here for 5 years does know, because it would help people get up their learning curve more rapidly." And one of the examples he suggested was, things like, after a while, after you've been here for a while, that Brent crude oil typically comes from the North Sea, and it typically has low sulfur content. It so happened we knew, we had the specifications for Brent crude oil. We knew exactly what range of sulfur content it could have, but was that low or not? And there's some subjective stuff there, and we certainly didn't have much information to say, oh yeah, it typically does come from the North Sea. And there's just tons of other, I just picked up one or two tidbits, that turns out that Shell Oil and a company called Vitrol tend to be the biggest trader of Brent crude oil forward contracts. So this is knowledge in that domain, and there's tons more.
Dave, we got
We
a hand raised if you want
oh
to deal with
yeah,
that.
I can't see them, so go ahead.
Danny, I think it is.
Dan. Um, so the knowledge that you're talking about, the skyscraper, like they tend to have steel frames and stuff,
Mhm.
and this wouldn't be in the A box, on instances. Is that because it's more just generalized
Yep,
knowledge and
yep,
maybe
exactly.
assumptions about,
Like,
a collection of skyscrapers as
Yep,
opposed to each individual instance?
yep, that's the exact pattern we're going to get to, and the trick
Okay.
is, it's not about an instance. It may not even be about the class. It might be about the class, but it may not be. It's just, and I'm going to go through about 5 or 6 more examples here, and yeah, keep those gears going, because what we're trying to collectively figure out is, what is this and where does it belong? Yeah.
Another hand from Michael
Yep.
Sullivan too.
Yep.
Sounds a lot like fuzzy sets.
Kind of.
Oh,
Yeah.
yep.
Yep. Yep. Keep that. Keep that thought in mind. So we have another client called the Center for Internet Security, and they had almost their entire business is in this sort of realm of distilled knowledge, and it isn't quite A box and it isn't quite C box. It's sort of interesting. They say things, and they say thousands of things like this. Strong passwords tend to mitigate the risk of unknown access. Yeah, duh. But how do you capture that? Where do you put it? And they even make a business out of people, millions of people subscribe to, knowledge like this. I'm not giving away all their secrets here, but, and you guys, if you've been in the business for a while, already know this, but the point is a lot of people don't, systems don't, things like securing the configuration process. You need to do that or malware gets into your production code. And if you simulate phishing attacks, you're sort of training your users to not fall prey to real phishing attacks. So this seems to be in that category of knowledge. We work with the International Monetary Fund, and they have, in fact, they're building a knowledge portal to surface a lot of this sort of knowledge they have. Much of it is very specific. A lot of it is ABOX. A lot of it is what's the GDP of Ghana and what's the inflation rate in Kuwait and all that kind of stuff. But there's also some more generic information buried in there somewhere, that as oil goes up, so does core inflation. Even when you take the oil out, the exact price of oil out, it's baked into food and shelter and all kinds of other things. They know that when local currencies inflate, exchange rates eventually subsequently fall. They know that and in fact, this is the whole thing they do. If you have a balance of payment deficit, you'll eventually have a currency crisis, etc. So that's kind of example of knowledge there. Life sciences, there are tons of this. I just picked 3 because they're sort of interesting. We say that the heart is typically in the left side of the thoracic cavity. We're not saying that an individual's heart is in the left side. Every once in a while, it's a weird anomaly, but sometimes people's hearts are on the right. Medical knowledge is things like statins lower serum cholesterol. That's almost a truism in the business, even though if you dig pretty deep, it's not purely causal in the way that Judea Pearl would say it was. And that, bad cholesterol is associated with higher incidence of heart attack, etc.
Got another question, Dave, or another
Yep.
hand up?
Yep.
Hopefully.
Yeah. So one of the things I'm thinking of here is that this is very close to probabilistic thinking in terms
Yep.
of Bayes and trees and other things, but it is also not that because you don't have the exactitude, if I understand you correctly. So I just
Yep.
wanted to raise that thought. Yeah.
Yep. No, right on. And it kind of fits in with a fuzzy
Yeah.
idea as well. But even with both of those, we're still struggling to figure out where do you hang that? Where you have to put the
Indeed.
probabilities on something. Yeah, that's kind of where we're going with this.
Brilliant.
We did a very small project with a partner company at PayPal, and at the ending of it, we found out that 20% of all calls to PayPal were about what's the status of my refund, and you'd think, wow, really? But it turns out they have all this knowledge, but it's scattered through hundreds or thousands of FAQs and policies and stuff all over the place. But it turns out, fairly simple thing, where your refund goes and how rapidly it gets there is totally determined by how was the original transfer made. If it came from your PayPal balance, the refund goes back into your PayPal. If you had a credit card attached to your PayPal account and you paid through that credit card, the refund will end up as a debit in your credit card account X number of hours later, etc. I mean, it turns out there's a real small bit of hyper important information kind of hidden in all these documents and stuff that just needs to get surfaced and put somewhere. So if those are examples, what is this stuff? I mean, at some level, this sounds like the Psych Corporation. They have spent 4 decades accumulating all, don't put bananas in the refrigerator and 2 physical objects can't, all that stuff. And it is knowledge, and it's common sense, it's human knowledge, etc. But that's probably way more than what we want to get into. And besides, they've already done it. They can have that. What we're looking for is is what's that subset of this that ties into enterprise knowledge that we need to capture, and where do we put it and what do we do with it? So that's what I think is going on here. And I started digging around a bit, and Gartner, as usual, says there's this thing called knowledge management. In fact, I first tripped to this, we were bidding on this project or trying to get this project with that project called The Line, NEOM in Saudi Arabia. And at one point we discovered that there was a short list of knowledge management software. And I thought, oh man, we're going to know all this. And they had this list of 5 or 6 companies that I'd never heard of. I go, wait a minute. I thought we were kind of in the knowledge business. How can all the leading contenders be people we've never even heard of? We don't know what this is. And of course, Gartner has knowledge management. And you read all this, it's a bunch of fluffy words to me, integrated approach to the creation, capture, organization, access, use of information assets, including tasks. And like, what? And of course, they have before we get to that, turns out you can become certified in knowledge management. There's, in fact, at least 3 different courses. I've downloaded some of their, I still can't quite figure out exactly what they're up to. I have a few theories, but if anybody knows, let me know. Here's Gartner's list of main players in the knowledge management business. And most of these I hadn't heard of. I've heard a couple of them. I'm scanning up and down this list thing. What is this? And then I see, look at that. Oh, okay, now we're on to something. Nope. They're using OWL for the wisdom and the cartoon. I mean, I read their whole website. I don't think they literally know what OWL is. They just thought that'd be the chief executive OWL and the technical OWL. And it's like, whoa, okay. And then I'm going around somewhere else and I find another list of the here's the top knowledge management companies. And you're in a fuzzy category when 2 people are independently building a list of the main contenders and there's almost no overlap at all. For those of you who are paying attention, the overlap was this company called Notion, which is a note-taking software. And, I wouldn't think of it personally as an enterprise level anything, but so here's another list of knowledge management software. And then, there's a company called Enterprise Knowledge. They're talking about a knowledge portal, which, also IMF, some of our clients are using that terminology. The reasonable definition here is the hub to bring together all your knowledge management assets, blah, 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 blah. And, but interestingly, they mentioned knowledge base, intranet, learning systems, digital twins. That's a bit of a stretch, but nothing about knowledge graphs and it's like, wow, it's like 2 ships passing in the night here. It's kind of weird. Then I went back. In fact, the top item on Gartner's list as a knowledge management company was Confluence, the enterprise wiki company. And I went, wait a minute, we have Confluence. It was sitting there right under my nose. I forgot to go look. And I thought, this is going to be thrilling. Maybe we've been doing knowledge management all these years and didn't even know it. Sort of like that guy that discovered he'd been writing prose all his life without knowing it. So I traipsed around in our internal wiki. And what did I find? I found emergency contact information, classic A-box, fun things to do in New York City, pretty much A-box-ish. Some guidelines on how to market and conferences we might want to attend, and this and that. But there wasn't much that I would really call knowledge in our own internal wiki. There's some advice and some ideas about benefit eligibility. And okay, some of that is knowledge, I suppose, but not very condensed and harvested and organized. It's just documents, really. So let's go back. If Confluence is an internal wiki, maybe the original, or not the original, but the main wiki out there, Wikipedia, gives us some clues. And if you go out there and look at Wikipedia, you take a page like Morgan Stanley, and you say, well, as we know, DBpedia harvested the info boxes over there on the right. They didn't read the text. They just said, you know, a bunch of name value pairs there, and the blue ones are object properties, and the black ones are data type properties. But you know, that's A box information. It's almost all factoids. We can capture them, we can link them. Very useful, but that's not knowledge like we're talking about. And then, you know, you read the rest of this text, and there's not actually a lot of useful knowledge in this particular page. You can go read it yourself. There's a few nuggets here and there. But now, if you go to another wiki page, I just randomly picked choline. In fact, I originally mistyped chlorine, but then I went, oh, choline, that's even better because it's got so many interesting properties and you know, much more bioactive and things. Now you look at this one, you go, hey, wait a minute, this is kind of different. It does have an info box, but if you read this info box, it's mostly a bunch of identifiers and cross references, and there's not great knowledge. There's a little bit, you know, atomic weights, a few things. There's not great knowledge over there in the info box, but man, that read this text, it's full of knowledge. How is choline metabolized? What's its function? What biopathways? They had further down all these pictures of, you know, which cycles is it in, what foods contain it, what are the health effects of, you know, what happens to you if you're deficient in choline, and also what are the toxic levels? They left that out, and how do you diagnose it? All that kind of stuff. You go, wow, this to me constitutes knowledge. And now we have a more interesting problem. If we knew that was knowledge, how would we capture it and where would we put it? And I decided to go look at a bunch of medical ontologies, figure out what they did. Almost all of them treat choline as a class. I looked up choline in a whole bunch of them, as you'll see in a minute here. But they're weird classes. You would never have an instance of the class choline. I might have a bag of choline or a sample of choline or what, but that would be an instance of physical substance, you know, categorized as choline. I wouldn't have a choline. Or, you know, very often for products, when we say something's a product, we really mean it's a spec. It's a description of things that are interchangeable. But actually, if it was a choline spec, it would be a particular kind of choline, like choline salicylic, salicylate, you know, with specific, you know, concentrations, all that kind of stuff. So I don't think there's a very good case to be made for it being a class. And weirdly, there wasn't much useful information. I probably went 7 or 8 ontologies and didn't find anywhere near as much as I found on the wiki page, which isn't the source authority. I mean, this is just a bunch of, you know, crowdsourcing people showing up and saying things about it, but it is pretty useful. You know,
Mike
you can go
Sullivan's got his hand up, Dave.
Yep.
Sorry to interrupt you.
Yep, go ahead.
Well, maybe it can be both a class and an instance via
Punning?
the technique called punning. Yeah.
Right. Yep. It may be. So yeah, let me keep going through with, you know, so yeah, in fact, I think that was what we may weirdly have to do when we eventually ingest a lot of these medical ontologies. Not so much, well, I suppose it would be punning. We're more interested in these things as instances of yet something else, which we'll get to in a minute. But so I went to, you know, this ontology called ChemB. You know, it's one they use in the chemical world a lot. They have identifiers and synonyms and a few roles, although not very specific. They're pretty generic, if I recall correctly. And interestingly, you know, they had it as a class, and it was a subclass of ammonium ion derivatives. Hello? No, thanks. Sorry. Which is in turn a subclass of polyatomic cations, which in turn is a subclass of polyatomic ions, which is in turn a subclass of polyatomic entities, which are molecular entities. Okay, that sounds sort of logical until we see some other examples. SNOMED adds in some products that choline is an active ingredient in, which is helpful. They said it's a subclass of quaternary ammonium compound, which is an organic nitrogen compound, which is an organic compound, which is a chemical categorized by structure, which is a chemical, which is a substance categorized by structure, which is a substance. And by the way, as most things in most of these medical ontologies, there's no definition, but it was hilarious looking at this page. There's thousands of things that are a direct substance of substance. Anyway. So I went to RX Norm and they added more ingredients. There was also a class there. I forgot to get the super glasses. The National Drug File added just one contraindication. I'm sure there's way more, but and some very generic mechanisms of action. They also had it as a class. It's a sub of C, preparation, whatever that is, drug products by generic ingredient, pharmaceutical preparations. And then finally, mesh added a lot of mappings, which is helpful, and alt labels. They also had it as a class of, they also went with quaternary ammonium compounds. But they had that instead as a subclass of ammonia compounds, which is a subclass of nitrogen compound, which bizarrely was a subclass of inorganic chemicals. Anyway, I'm ranting. So here's my take in general on this. We're going to see more and more of this. I think it's always been there and we've been kind of ignoring it. I think we should start thinking about it kind of the way we do taxonomy management, not allowing it to be some separate thing that somebody else manages and has a knowledge base and isn't integrated at all. We have to figure out some way to bring it in to be integrated with the knowledge graphs, all that kind of stuff, without, going wild and trying to capture all knowledge.
Michael's
So-
got his hand up.
Yep.
Michael, you're on mute.
Sorry, yeah. So one of the first thoughts that come to mind, especially with your earlier examples, is this notion of a whole research area back in the day called default knowledge, prototypes.
Mm-hmm. Yep.
There might be something there in that literature.
Yeah, that is a good one. Yeah. Yep. In fact, that, weirdly, that ties into that conversation about penguins, doesn't it?
Yeah, and also the other thing is a lot of it's prototype stuff, but then some of it's rules.
Yep.
Causality rules.
Yep.
Which is sort of different.
Yeah, absolutely. Yep.
Rebecca
anyhow,
is up as well.
Yep.
What? Oh, yeah, I was going to say, I've encountered a lot of examples like this dealing with internal operations at IDA. I think you would say they're examples that are typically called business rules. And, the question, like, for example, a pay period is 2 weeks long. Well, that shouldn't be the definition of the class pay period. But it's knowledge that people have within the company that drives things like payroll and billing. And you call that business rules and you just kind of shunt it aside. Oh, that's a business rule. But we don't want it to go into applications for the same reason we don't want the model to. So I've asked that question too. Where should that go and how does that get formalized?
Yeah, those are good. Those are also good examples. Yeah, I know we've mostly been ignoring this stuff. Not totally ignoring it. We acknowledge it, but we don't have a good place to put it. And this may or may not be it, but I'm going to give it a try. I'm going to suggest, lately internally, we've been talking a lot about horizontal and vertical subgists. There are some, gist is just kind of a framework or a scaffolding that most concepts can hang on. And we've been discovering as we do more and more projects, almost everybody has HR, many people have accounting, those are nice horizontal specializations of gist that you may or may not want to include. And we haven't made them public yet. Partly they're all work in progress kind of things that we bring to our clients. And we may eventually make them public when they stabilize. And then there's vertical subgists, industry specific things like professional services or financial services, etc. So this may be a horizontal subgist. It may have a class called something like concept. where we're going to deal with things like choline. Maybe, in fact, it might be a little confusing to have another concept when we have SCO's concept, but and I you know, this is just still very preliminary. Maybe we could reuse SCO's concept. We'll have to kind of look at that. It's a little bit like category, but we're going to be allowing a lot of properties on these things, and that kind of gets not quite in the spirit of where categories were, which are just, simple tags for the most part. So one of the places where I tripped to this, and I use as an example, we were doing one of our early projects at Goldman Sachs, and I had our business development person at the time with me, and she very much wanted to understand how this semantic stuff worked and describe it simply to people who didn't understand it. And we finally get this meeting with the director's boss. So we're at a pretty senior place, and the director's boss says, so what is all this semantic stuff? And the biz dev woman says, well, I'll give you an example. In semantics, you can say all dogs have 4 legs. And this woman just doesn't miss a beat and says, well, my dog has 3 legs. And it's like, oh man, all the air goes out of the room. And you think, yeah, really, that's a horrible example. All dogs don't have 4 legs. And it's not part of the essential definition of a dog. What we, I think, really want to say is that a dog typically has 4 legs. That's something we know about dogs, but it's not dogness, if you will. It was just so embarrassing. It took a long time to recuperate from that part of the meeting. So you come to a fork in the road here. At one point, I was thinking all this extra knowledge could just be object properties. You could cover a lot of things with object properties, but that previous example with the dog kind of scared me off. I think you can casually get into the habit of just writing down whatever you hear as if it's true. And then pretty soon your ontology is unwieldy and full of sort of proto-truth and things like that. So I think there's some danger there. If we had dog, if dog is an instance, you can't write a restriction on an instance, right? And you kind of wanted to do something that sort of looked like a restriction. If you make dog a class, then you go sort of where the medical world has gone. There's hundreds of thousands of classes, and you can't infer, and they aren't very helpful anyway. So if we stick with this idea, most of these concepts that we want to have knowledge about, the knowledge pretty much has to be a predicate, and it's they either are going to be object properties or annotations. And at the moment, I'm feeling safer with annotations, but we can do some experiments here. Here's a prototypical definition of what we mean by a concept. So the class of all concepts contains instances, each of which is one unit of knowledge, whatever that is. But very often these are aggregated from experience, not literally aggregated, but we have things that happen to large populations of people, and then we generalize from that. So we learn a lot from a chemical like choline, or a product like a 529 retirement account. There's things that are just typically true about them, or your thorax, or a condition, or maybe even risk. And there are,
whenever you want to.
yep. Yeah, I'll just finish the paragraph and then I'll let you go on.
Sure.
There and there may end up being relationships between these concepts, if or things that are real. Brent crude, a concept, is found in North Sea, a real place. But we could also say crude oil is found in underground reservoirs, both of which are just conceptual ideas. Okay, so fire away.
I have 2 questions. So the first one is, could you just use SCO's concept for this rather than defining a new class? secondly, it seems to me there need the rules or the knowledge needs to be formalized in some way, not just in annotations. Otherwise, how can you, like in my example of a pay period being 2 weeks, you would want this to somehow drive, you know, the operation of doing payroll, and you can't do that if it's just in an annotation.
Well, let's see.
Yes,
So
you
let me
can.
do the first. Let me do the first one first, and the second.
Okay.
So a couple slides ago, I did suggest, yeah, we may want to reuse SCO's concept. I think we should build a bunch of examples. There's a risk because obviously SCO's had something in mind when they coined that term, and is there exactly a one-to-one correspondence? We'd want to check that out and see if that was okay, and it might be. On the other side, it doesn't mean that just because something's an annotation, you can't do anything with it. We used to take annotations and actually write code that did something with the annotation. And in some ways, it's safer to do that. If you make it an object property and try and do something special with it, the reasoner is also going to try and do something special with it. And you got to make sure, I didn't want that to happen, but it happens anyway. So anyway, but yeah, we're gonna have to go through, I think, a lot of examples and figure out maybe it is object, or maybe some things are object properties and some are annotations. I don't quite know yet. So next question. Is there another one?
Might be me.
Yep.
So a lot of the tools like Pool Party and all that, they're kind of already in bed with SCOs. And also SCOs has some of those, not all of them obviously, but some of those fuzzy-like things, and so that, instead of, exactly alike, they have the concepts of similar to and things like that nature. So you're already halfway there. So, and the other obvious thing is that, not so obvious maybe, is that perhaps a way of looking at OWL is more like Java, and SCOs is more like JavaScript. There's a need for both. And I would say, embrace SCOs, make it, just show best practices in terms of punning. I think that's something we're certainly considering on the Oracle and energy and water ontology. And also the reality is there are all these SCOs taxonomies out there anyway. Why not just kind of use them as is? And I think, I think that would be more pattern oriented than product oriented, but still very useful and valuable.
Yep. Oh, good one. Is there
Mike
any more
Ushold,
questions?
yeah, there's 3 more hands. Michael Ushold first.
Yeah.
I've touched a nerve here, I think.
I forgot what it was. I'll come back to it.
Yep.
Pete Rivet.
Hi. So it seems to me it's not so much what the information is about, whether it's a class or an instance or a concept. It's more about the way in which you're saying it, i.e. the triples. It seems to me what we could try and leverage is something that annotates the triples rather than the nodes, the edges rather than the nodes, i.e. building on RDS star, which has provided a base level capability that a lot of knowledge graph products already support. And we should be thinking more about different ways of modeling annotations on triples, because RDS star itself doesn't say that. And that's a big gap that I think the industry or people like us should be looking at, is how to build the equivalent of ontologies to have a more standard set of annotation properties on the triples. I think that's not a complete answer, but I think the direction we should be looking is not the things that the knowledge is about.
Yeah, no, that's interesting. 2 interesting things there. RDF star, I hadn't even thought about that going into this, but that's a great one. And did you say that you cannot annotate annotate annotations in RDF star? I didn't even realize that.
You can annotate pretty
Oh,
much anything.
yeah.
Yes,
Oh,
so,
good,
yeah.
good, good. Yeah, yeah. That might be interesting.
I guess
Just-
it's very, very low level. It's just about adding extra properties to triples.
Yep. Who's next?
Justin Dowdy.
Hey, Dave. A lot of your examples made me, well, specifically the ones from IMF about whenever you've got inflation as a variable and what things affect that. It made me think of mathematical models. Even the one about the cholesterol. What's cholesterol's effect on the body? I feel like mathematical models are like often implicated in those kinds of conclusions. So maybe that's a kind of, maybe we introduce the structure. Here's a mathematical model. Under this model, that here's a causal sort of story. So I wonder if that's a useful thing to invoke.
Yeah, and certainly there's going to be some math, like in the examples Rebecca had, of just figuring out very mundane things like what day is payday. Yep.
Michael must have remembered what he had.
Yeah, it's amazing how useful a pen and pencil is. Anyway, so Dave, I wondered whether you have gone to the extent of thinking of competency questions. Because I think, as I said earlier, there's different types of things going on here. There's this notion of prototypes with default reasoning, which might be true some of the time, might not. And then there's rules, causality rules. And some of what the challenge is it's not logical deduction always. All about logical deduction.
Yep, exactly.
So I think there was one other example which you could flick up. Anyway, I'll look at it later.
Yeah.
But, there's different types of things going on here, and competency questions will probably look differently for each of those 2 or 3 major types.
Yeah, that's a great idea. I hadn't thought of that. That's a good one. Any more questions?
That's all the hands.
Great. I got 10 more minutes. I think I'll make it. So I just made up a couple of a starter set here. I just went through those examples and said, now they don't have to be annotations, but if they were annotations, here's some. And for instance, causes, the one at the top of the list, there's a whole lot of these things where X causes Y, or drugs interact with each other, things like that. But if you really study this, you realize, no, X doesn't really cause Y. There's a whole bunch of complex interaction, much deeper, that hasn't been captured, maybe isn't even known yet. Sometimes it's known and isn't captured. We just boiled something up that says X typically causes Y, or sometimes, or occasionally, or whatever. So, I was tempted to put these things in the GIST namespace because that's what I'm always tempted to do, but and especially if I turn them into object properties, it's too easy to think that these are, real object property kinds of assertions, and that they're true and they hold. And you sort of look at all these X contains Y and X is found in Y. Really, they capture what that guy from S&P first said, that this is what's typically true. Brent crude is typically found in the North Sea, and these symptoms are typically found with these diseases. They aren't absolutely and totally and always true as they are now. So I kind of like, when I was reading these, I sort of like reading TYP to be typically, and that seems to kind of work for a lot of these. To sum this up, I think there are cases where we want to capture something that's close to pure knowledge. We want to try and get it integrated in with our knowledge graphs rather than having it somewhere else in Atlassian or something, which is just not useful. You're not combining that with everything else the enterprise knows. And this idea that actually all what the enterprise knows is going to collapse in their knowledge portal of documents seems, I don't know, like not a great idea. We have a much better way of organizing information and knowledge. Information, let's say. Let's put some knowledge in that, and we'd really make some progress. I don't think most of the things that we're talking about here are in our classes. I think looking at a lot of the life science ontologies is pretty discouraging, I think. But we do want some small amount curated in the graph, mostly for human consumption, or some programs or some rule engines or something. I kind of think we need to work through a lot more examples. But today I just wanted to see whether this was scratching an itch that other people have, whether you've seen similar things, whether there is an answer, or if there isn't, we should just go create one. My last little bit of thought, and then I'll take some more questions, is to get a little bit of inspiration from the football team, the Cornhuskers. I know many of you know that N on their helmet stands for knowledge. So with that,
Michael Sullivan.
Yeah, in our case, we're considering punning and using SCOWs. One of the problems is that Oracle's database doesn't is using OWL RL, not OWL. What is it? DM? Is it? Yeah, DL.
Yeah.
And so we'll have to basically extract any punned inferences and then load them manually into the database. So some just different database vendors have different reasoners, and that's obviously puts a fly in the ointment.
Yeah, doesn't punning also put OWL into full? Doesn't it make an OWL full when you pun? It doesn't?
No,
Okay.
it's a cheat around it.
Okay.
Yeah, it's not. Yeah.
Certain
Okay.
kinds of punning do, but certain kinds don't.
Okay.
Jonathan Storm. You're muted, Jonathan, if you're talking.
Yes, I just wanted to say I love the way this is going. I do have data like this, and I think the typically namespace and those initial predicates just look great.
Cool, thanks. Yeah, I'm thinking maybe the next thing we should do is have another session and just have people bring examples. A lot of times what you need is just a whole bunch of examples. What would you do? How would you deal with it? And why did we ignore this in the past? Or what did, sometimes we don't ignore it. We deal with it, but in some ad hoc way,
We'll take you up on that. We have plenty in the energy and water space.
Cool. And we got Javid and Michael. Javid, are you muted? Doesn't look like it, but we can't hear you.
I'll loop back to you if
Yep.
we can go.
So Michael and then Rebecca.
Yeah, these typical predicates are quite interesting. However, what you end up with, so let's just take found in, is typically found in. But then there's another thing that we would have as a regular object property is really found in. So we would say,
well, we would say geographically contained in. That's where you find it.
The point I'm trying to get at is there's going to be parallels, typically X and actually X.
Yeah, but the difference is the concept is typically found in a region. The actual, tanker full of oil did come from a particular place. It's not typically coming from anywhere. It came from right there.
It's working at the class level, not the instance level.
Yeah.
But they're still sort of parallel universes.
Yeah, absolutely. Yep. Rebecca.
Yes, so I do also like the idea of the different annotations, but regardless, if you want this to actually drive operations like a pay period, or to come back to that example, triggering something happening, there has to be some structure to the content of those. They can't just be for human consumption.
Right. But it may be it's being consumed by another program, not the OWL reasoner, but something we write ourselves.
Oh, yeah, I don't mean the OWL reasoner, except that it shouldn't be, it seems to me you still want to be data centric in that there may be several applications feeding off this knowledge. So you don't want to bury it in those applications.
Yep, exactly. Yep. Good thought. And Javid, did you get your mic to work?
Yeah, he said he's having issues with his mic, but the question was, assume we built a knowledge ontology, how would one consume it? Will it be reasoners or some other ways?
Yeah, great question. I'm thinking it's not reasoners, because I think anything that we could reason over, we would put in the A box, the C box, or the T box. I think this is for the things that don't fit those patterns. So I think we have to do something else with them. We may have to write our own. In fact, I would love to have it in the architecture, not in an application. That's I think where Rebecca was going. So if we had some formal way of expressing some of these, almost rules or insights or whatever they are, that we could either surface to humans or to a certain part of the architecture that could deal with it, then I think we got a winner.
There's some interesting back and forth in the chat about typically, and then some probability that speaks to likelihood or being a specific use case.
Yep. Yeah, absolutely. And again, that the probability is a classic for attributes on the edges, RF star, RDF star. Yep.
That was me, and some of the labeled property graph stuff I worked with in the past kind of dealt with this too. And to your point, Dave, about kind of getting to the edge of where a reasoner can go, and then you have maybe some other kind of machine learning or something that's deriving how often something can be classified into something else, and then you can kind of store that probability or store the rules around that. Yeah.
Yep.
One more in the chat. Would insights from this ontology be encoded in the same way? Oh, and you raised your hand. I don't know if you still want to ask.
Yeah, I could comment on that one.
Yeah.
So I'm thinking that, often we derive some kind of knowledge based on reasoning and other things. It's not definitive in the end, but we get a better idea about the world thanks to the contextualization and the added knowledge from other locations. And thus we would like to encode that probably in the same place or next to it. But the question is, how do we connect that to what we have and the inferences haven't been made?
Yeah.
Would this be kind of the same thing?
I think so.
It's close.
Yeah, and in fact, you're just reminding me of another thing I should have included in here. This whole business of data scientists churning through big data and getting insights. But then where do those insights go? They just go, poof, they go in a spreadsheet somewhere. And, you go, wait a minute, that's not in the spirit of this at all. What you're suggesting is we should have some way of getting knowledge from knowledge. Inference is one way, but it's not the only way. And we should be able to get an insight and put it back in the graph so everybody else can have the insight.
And also that it will be invalidated if the original information is somehow changed.
Yeah. Yep. Peter.
So one of the things that I think is maybe I'm unaware of it, but I'm thinking that it's missing is that in our knowledge graphs, everything has got an equivalent status, and that actually some triples might be more suspect than others. And if there was a way of providing a kind of gradation of, this is speculative inferencing, this is a hard fact, this is something that I've kind of got a feeling about, then what we could do is bring in different levels when we're looking at our queries or our inferencing, and that I think might enable people to feel a little bit more easy about putting stuff back into the graph, if they could say that this is unvalidated, but I'm putting it out there, whereas other stuff is rock solid.
Yep. Yeah. Yep. It does sound like another case for RDF star, doesn't it?
Yeah, it really does. Yeah.
Cool. Well, I am going to wrap up because I have to take someone to
with
PT
RDF
here.
star is that it talks more to the relations about things, whereas actually, you want to know about your subject and object, how certain you are of those.
Yep. Okay. Thanks, everyone. I hope that was interesting and intriguing, and maybe we'll have part 2 next time.
Yeah, that was awesome.
It wasn't daft.
Oh, good. Yay!
That was awesome.
That's all we needed. We just need to get, I just wanted to get the conversation started, really.
Thank you, Dave. That was perfect timing.
Great.
And remember, folks, with our kind of revamped here, we won't meet next month. It'll be the following month. So I'll be sending out emails and events and everything from there, and we will see you all soon.